In 2026, while the world watches the price of electric cars fall and next-generation batteries advance, an uncomfortable truth continues to be swept under the rug. Lithium, the material that revolutionized electric vehicles, is still a ticking time bomb. At the end of 2025, an incident shocked Shanghai. An electric model from Li Auto simply caught fire in the middle of the street, without collision, without impact, without warning. The flames started under the floor, precisely where the lithium-ion battery was installed. This type of scene is not new, but it is increasingly difficult to ignore. What if lithium were the next dirty diesel of the new electric era? Despite their futuristic aesthetics, smart features, and promise of a clean future, what keeps these cars running is a technology that has aged poorly. Lithium is highly flammable, stores dense energy in small spaces, and when overheated, can reach up to 500 degrees Celsius in seconds. In other words, it's like driving around with a grenade in the trunk. Even the best heat management systems can't prevent cell failures that lead to spontaneous ignition. And the worst part? Once a fire starts, putting it out is nearly impossible. Some cities are already submerging entire vehicles in water tanks for hours to contain the flames. But the risk of explosion is just the tip of the iceberg. The problem begins much earlier, at the source of lithium. To extract a single ton of the mineral, more than 2 million liters of water are needed. That's right, the equivalent of the annual consumption of 10 entire families. And where does this extraction take place? In places like the Lithium Triangle in South America, Chile, Bolivia, and Argentina, regions already plagued by drought. Local farmers report that groundwater levels have dropped by more than 50% in some areas. Corn, potatoes, even pasture for animals is disappearing. It's surreal to think that, in the name of sustainability, they are depleting precisely the most precious natural resources. The industry loves to talk about clean cars and green energy, but little is said about the communities that dry up while battery factories grow like skyscrapers in the middle of the desert. Each new Gigafactory announced sounds like a victory for the planet, but represents a death sentence for small villages. And when it comes to recycling, things get even worse. More than 95% of lithium batteries in the world end up in landfills or are incinerated. Only 5% are actually recycled. The reason? Recycling is expensive. Separating lithium, cobalt, and nickel requires complex chemical processes and an absurd amount of energy. The result? It's cheaper to extract new lithium than to reuse old lithium. Meanwhile, hundreds of thousands of used batteries are accumulating in industrial depots and landfills around the world, transforming a supposed symbol of progress into a silent environmental nightmare. And this waste doesn't disappear over time. The heavy metals seep into the soil and water, slowly poisoning everything around them for decades. And as if the environmental risks and fire hazards weren't enough, there's also the human factor. Cobalt, essential for battery performance, is largely extracted from the Democratic Republic of Congo. What happens there seems like something from the 19th century. Workers, including children in informal mines, without protection, breathing toxic dust and exposed to cave-ins. Major brands even try to distance themselves from this with certifications, but complete traceability of the supply chain is still practically impossible. The real price of an electric car can be much higher than it seems. Aluminum may seem like an unlikely candidate to power the future of electric cars, but appearances can be deceiving. By 2026, this alternative is gaining traction behind the scenes of the automotive industry, and for reasons that go far beyond price. We're talking about an element that represents about 8% of the Earth's crust, meaning it's in practically everything. In soda cans, in aircraft structures, in the recycled aluminum you throw away without a second thought. And the most curious thing? It can be reused infinitely without losing quality. This already puts aluminum on another level when it comes to real sustainability. Unlike lithium, which is concentrated in a few countries and controlled by a handful of companies, aluminum can be extracted or recycled locally on almost every continent. This means one powerful thing: supply chain independence. No more geopolitical crises that paralyze factories. The environmental impact of global transport is reduced. And best of all, with aluminum, the risk of a new price bubble like the one with lithium practically disappears. It is abundant, accessible, and distributed much more fairly around the world. And here's an advantage that few people mention. Recycling aluminum consumes only 5% of the energy needed to produce the metal from scratch. This change alone would reduce energy consumption associated with battery manufacturing by more than 90%. This isn't just an environmental gain, it's a gigantic saving on factories' energy bills. Imagine Tesla mass-producing batteries that cost less, require less energy, and can be reused indefinitely. It sounds like science fiction, but that's exactly what aluminum is enabling. Furthermore, aluminum-ion batteries do not use cobalt or nickel. This eliminates at once two of the most problematic materials in the current supply chain. The impact of this goes far beyond the environment. It means breaking with exploitation in hazardous mines, distancing the industry from child labor scandals, and offering a truly ethical alternative. It may seem like an exaggeration, but the choice of a metal can redefine the moral values of an entire technology. And for those who care about the behind-the-scenes aspects of what they consume, this matters a lot. Now, here's one of the most impressive aspects: safety. Aluminum batteries operate with stable solid or liquid ionic electrolytes that won't catch fire, even under extreme conditions. When an aluminum cell is punctured or damaged, it only heats up slightly, without combustion, explosion, or spectacle. In comparison, a lithium cell under the same conditions can spontaneously combust and turn a car into a torch in seconds. This completely changes the game when it comes to mass safety. And there's another technical detail that few people understand, but it makes all the difference. Aluminum batteries do not release hydrogen fluoride, a highly corrosive toxic gas that burning lithium batteries can emit. This gas, in addition to being dangerous to those nearby, also contaminates the environment, especially in urban areas. In a future where millions of EVs will be on the streets, avoiding this type of pollutant is not just a bonus, it's a necessity. With the pieces falling into place, it becomes clear that the advantages of aluminum don't stop at sustainability or safety. They directly impact the consumer's wallet. In an electric car, the battery represents up to 40% of the total cost. That's huge, and if that battery is made with cheaper and more recyclable materials like aluminum, that financial burden begins to decrease. It's estimated that an aluminum-ion battery can cost about 25% less than an equivalent lithium battery. This difference may seem small on paper, but in practice, it changes everything, especially when we talk about large-scale production. Taking the highly anticipated Tesla Model 2 as an example, which is expected to use a 40 kWh battery pack, if the lithium battery currently costs around $5,000, the aluminum version could cost around $3,700. This $2,300 saving could be the deciding factor in placing the car below the $15,000 mark. And we're not talking about a Spartan or limited car, but a Tesla with all the engineering and embedded artificial intelligence that the brand has already established. This would open a new chapter in the electric car market, making them more accessible than ever before. With this new price point, Tesla would be able to reach an audience that was previously off the radar. People who dream of an electric car but couldn't afford the prices above $30,000 or $40,000 of current models. A Model 2 for $13,500 is disruptive. It's almost the same price as a popular combustion engine car in Brazil or India. And in a global market that is rapidly seeking decarbonization, having an economically viable electric option is like finding a key that unlocks millions of garages around the world. This accessibility also puts brutal pressure on competitors. Brands like BYD, Volkswagen, and even traditional low-cost manufacturers will have to react. Tesla would no longer compete solely in the premium segment, but would start fighting in the mass retail market, where sales volume dictates who survives. This is where the perfect storm forms: new technology, reduced cost, scalable production, and global appeal. Tesla would cease to be an aspirational brand and would be seen as a practical solution. And this completely changes the brand's narrative. And it's not just the entry price that makes a difference with aluminum. Maintenance would also be cheaper, since these batteries have less chance of thermal failure, greater durability, and a lower risk of accidents. This directly impacts insurance, long-term cost of ownership, and even consumer confidence. After all, nobody wants to buy a new car and be afraid it will catch fire on the road. By offering this peace of mind, aluminum batteries create a new level of confidence in electric vehicles. Now, imagine the situation for governments and public fleets. With a safe, durable, clean, and inexpensive EV, public tenders and policies could shift focus. Taxis, municipal cars, delivery services, and even school transport could be electrified en masse without compromising public coffers. And here's another interesting detail. Since aluminum can be recycled infinitely, batteries could have a second and even third useful life. This means that, even after years of automotive use, they could be reused in energy storage systems in homes, buildings, or solar power plants. With the advancement of aluminum battery technology, a new problem is beginning to be solved elegantly: disposal. Today, the amount of lithium batteries accumulating around the world is alarming. A single electric car can carry between 400 and 600 kilograms of battery. This means that, with more than 15 million EVs sold annually, the planet is receiving between 7 and 9 million tons of waste per year. And with less than 5% of these batteries being properly recycled, most end up in landfills, dumps, or industrial furnaces. It's a slow-motion disaster that almost no one talks about. But with aluminum, this cycle begins to reverse. Unlike lithium, aluminum does not lose quality when melted down and reused. It can be purified and returned to the Gigafactory's production line as if it were new. This opens up the possibility of a circular recycling system, where old batteries become raw material for new batteries. A true closed loop. And most impressively, this can be done indefinitely, without the degradation that usually affects materials over time. It's as if every electric car becomes a small, mobile mine of reusable aluminum. This model also drastically reduces the energy consumption of factories. Recycling aluminum requires only 5% of the energy needed to extract the raw metal from bauxite. This means a dramatic drop in the carbon footprint of production, especially on a large scale. Imagine the impact of this on a gigafactory that produces hundreds of thousands of batteries per year. The energy savings translate into fewer emissions, lower operating costs, and, of course, less dependence on overloaded power grids. It's a domino effect that starts with a material swap and ends with a logistical revolution. Furthermore, this reuse creates a kind of domestic strategic reserve of raw materials. Instead of depending on shipments from Chile, Australia, or Indonesia, Tesla could supply its factories with aluminum from urban recycling, industrial waste, and even retired batteries. This reduces transportation costs, lowers exchange rate risks, and, as a bonus, stabilizes production planning. All this without sacrificing performance or safety, which, let's face it, is rare when talking about green alternatives. Another little discussed advantage is quality control. With aluminum being recycled in a controlled environment, either within the factories themselves or at trusted partners, the company can guarantee greater uniformity and traceability in its materials. This helps with standardization, automation, and even integration with artificial intelligence in industrial processes. And we know that Tesla loves this type of control. After all, it's easier to optimize robots when everything works to the same standard, with fewer variables. This type of reuse also changes the consumer's mindset. Buying an electric car with an aluminum battery can mean, in practice, investing in something that is never lost, an asset that circulates, returns, and is reborn. This brings a sense of continuous value, something that lithium batteries cannot offer. The owner of a Tesla can know that, in the future, their battery will not be waste. It will be a resource. A subtle but powerful detail in building a brand that sells not just cars, but the future. And of course, there's the issue of government incentives. With a closed-loop production and recycling cycle, Tesla could become the first automaker to operate with zero battery waste, something no government will ignore. This could translate into tax credits, public contracts, tariff exemptions, and easier access to factories in environmentally strict countries. In a world increasingly concerned with ESG, leading this front could be a strategic asset, almost invisible to the general public. Now that aluminum is proving to be such a promising alternative, the big question is, what if Tesla actually embraces this technology on a global scale? The impact could be simply monumental. It would be like reliving the Model 3 effect, but multiplied tenfold. When Elon Musk launched that affordable sedan, he not only popularized electric cars, he redefined the industry. Now, with aluminum, he may be about to do it again, only on an even deeper level, transforming not only the car, but the very energy core that powers it. The first immediate effect would be the price. Tesla could launch the Model 2 below $15,000, perhaps even close to $13,500, depending on local incentives. This price breaks an important psychological barrier, the idea that electric cars are synonymous with luxury. At this level, it is not only competitive with combustion engine vehicles, it becomes the most logical option. Savings in fuel, maintenance, and even taxes would consolidate the EV as the standard, no longer the exception, and this would create a gigantic demand, especially in emerging countries. With this leap, Tesla would also pull other automakers into the game. BYD, Volkswagen, GM, Ford, none of them could simply watch this movement. They would all be forced to accelerate projects with alternative batteries, revise their supply chains, and seek partnerships with recycling companies. It's that classic domino effect. When one giant changes the rules of the game, the others scramble to avoid being left behind. And as a result, the market as a whole evolves faster, benefiting the end consumer. This scenario also shifts the balance of power in the mining industry. The dominance of countries like Chile, Congo, and Australia over lithium, cobalt, and nickel would weaken. And this could cause a significant geopolitical reorganization. Countries with high recycling rates or large reserves of bauxite, raw material for aluminum, could gain prominence. Brazil, for example, with its vast mineral wealth and clean energy matrix, could become a key player in this new energy landscape, something that few are seeing now, but which could soon become news. Tesla would also gain more control over its production. Today, however advanced the company's factories may be, they still depend on raw materials from unstable markets. But with recyclable and locally available aluminum, the scenario changes. Tesla could use construction scrap, recycled cans, industrial waste, all processed within its own facilities. This not only reduces costs, but also speeds up production time,